Hey Megan, it's Mrs. Walker. It is Monday morning, September 15th, I believe. And I hope you had a good time at the Wilds. I've seen a lot of pictures. It looks like y'all had a great time. And that's wonderful. And now back to reality. The good thing is you didn't miss anything last week since you were the only student missing from the class. And so I'm excited to get back to work. And I apologize for not being there today. I got one of my little girls is sick today. So thankfully, you'll be able to still get a little bit of work done and kind of get back in the groove today. So I thought I'd make this video for you to let you know what we're going to be doing. I'm going to stick with the review lesson. I think we've got 2 more lessons, and we'll kind of spread it out throughout this week and probably do a test next Tuesday right before we are off again for the teachers convention. So we're still working with trinomials here and factoring and all. And so I've given I've sent a worksheet for you to work on, and it will be similar to what we were doing before you left on your trip. And so just take a look. Hopefully it won't be too bad. The first page is just a review of simplifying rational expressions, where you've got basically a fraction and you want to cancel any common factor that is in both the numerator and the denominator. And then always remember to factor first. If you've got a trinomial, then factor it into 2 binomials. And you can only cancel if you've got a binomial that is the same in the numerator and the denominator. And so then on the second page, you will have some back to multiplying and dividing with rational expressions. So I was going to review this one with you right now. And so what you want to do is take your numerator here in the first fraction. And my apologies, I'm not that great with this pen, but I'll do my best. Okay, so I'm going to take this a squared minus a minus 2. And remember, you're going to factor those, that trinomial. And so you're going to go a and a, and then 2 numbers that add together to give me a negative 1a, because this is an understood 1, and then multiply together to give you a negative 2. So it looks like it's going to be a negative 2 and a positive 1. And then the denominator, same thing. We're going to do a and a. And then be thinking here, negative 1, sum is negative 1, product is negative 6. And so I think we're going to do the factors of 6, of 3, and 2. And you should be thinking as I'm writing. Hopefully you remember this as well. Let's go with a negative 3 and a positive 2, because the sum of negative 3 and positive 2 is going to give me a negative 1. That goes right there. All right, this is a division problem. My apologies. I scanned it and then had to pull it out, but that is a division problem. Remember, when we're going to divide rational expressions, we're going to actually multiply by the reciprocal of the second fraction. So I'm going to take 2a plus a squared, and I'm actually going to write it in factored form to kind of speed things along. I've got to get this video to you. Okay, so I took my denominator here. I'm going to put it into the numerator when I multiply by the inverse. And so I factored out an a from both terms. And then my numerator here, a squared minus 2a, I'm going to factor and put it into the denominator. So they both terms had a factor of a. And we're going to go a minus 2. Okay, so that hopefully bring back to your remembrance what you're supposed to do. And factor everything. Really what it is this is all a product all the way across here. And this is all a product all the way across. And once you have everything factored, Now we can compare numerator and denominator, and looks like there's an a minus 2 here and an a minus 2 here, so cancel those. And then we got an a plus 2, and this says 2 plus a, but basically that's the same thing, so you can cancel those. You got an a here and you got an a here. And so even though it kind of looks pitiful, you can see that we've got a plus 1 remains in the numerator and a minus 3 remains in the denominator. Final answer of a plus 1 over a minus 3. And that would be what you would write for the final answer. Of course, you can always do them with parentheses or not, especially if there's more than one in the numerator denominator. So that would be my final answer right there for the first one. Okay, then the second one here, I was going to show you how to do when you've got cubes. This right here, this is back to a multiplication problem. And so when you go to do, I'm just going to run this whole thing together here. Oops. You know what? Let me do a line. Let me grab a line, because that'll look nicer. There, that's better. And let me erase this one. Okay, so I'm going to run this whole numerator here together. And so when I go to do x squared minus y squared, let me see if I can do a text box, and that may be even easier. Okay, x squared minus y squared, you would have x plus y times x minus y, right? Because it's a difference of two perfect squares here. X squared minus y squared, difference of two perfect squares. Okay, then this one right here, don't let that scare you. It's not too bad. It'll be x and x. And then this last term is y and y. So you would put a y as your last term as you're trying to factor the trinomial. Y. And then notice both of these are positive, and so if you'll just put a positive sign here and a positive sign here, you actually have got it. Okay, and then y cubed minus x cubed, x cubed minus y cubed. Okay, I'm going to go down here. Put this format, write this format down. Whenever you are factoring and you have a to the third power minus b, this just means anything to the third power and the difference when you have it to the cubed power. Okay, it's just kind of like anything else. It's got a little format. So when you have two quantities cubed, you do like this. You go a minus b times a squared plus ab plus b squared. Okay, this is going to be the format that we use. Let me put a parentheses down here. Okay, this is the format that you use to factor something like this. So all we're going to do is, because this one right here is x and y, wherever you see an a or an a, you're going to replace it with the x here and here. And wherever you see a b, you're going to replace it with a y. Okay, so I'm going to use this format and factor x cubed minus y cubed. And I'm going to put it right here below the line. squared. That's how that one would be factored. And then this trinomial right here will be x plus y times x plus y. And you know what? I need to go back up and correct this one. I just realized that this right here, I need to correct it. It actually should stay that way because the middle term needs to be, would be 2x. So let me redo this one and then I'll pull it back and I'll explain it. Okay, so here it would all be factored, and this line just needs to pull back. No, you can't do it. Okay, x squared minus y squared, see if that makes sense. X plus y, x minus y. Okay, this one right here, I thought it would factor, but when I looked at this bottom trinomial, I realized that x plus y times x plus y is actually the factoring of, would result in this trinomial. This one couldn't be factored because when we had the xy and xy, it would have been 2 right here. But when I did y cubed minus y cubed and use this format, you see that the trinomial here is exactly the same as the trinomial here. So that we can cancel, as long as the trinomial is the same on numerator and denominator, we can cancel those. We can cancel an x plus y and an x plus y, and we can cancel an x minus y and an x minus y. So my numerator all cancels, but remember it's still 1, and my denominator is just x plus y. Final answer here, 1 over x plus y. It's easier to type it. Okay, hopefully that makes sense. If you just look at it for just a minute, that would be, this was the new thing that you should write down, is make sure you know how to factor a cube. A cube. Let me see if there's one more. I had a bunch of examples, but I may stop it early here. Okay, this one has a sum. So let me show you how to do this one right here. The format when it's a sum, a cube, that's a sum, is very similar to when it's a difference. But this time the format is a cubed plus b cubed. And that one is going to be equal to a plus b times a squared minus ab plus b squared. Right, so when you have, I showed you the difference when on the other problem. Now write down this one will be when it's a sum, when it's cube of 2 sums. All right, and so this one is c cubed plus 8. Notice 8, you have to write 8 as a cube, and so we're going to use this. It should be c cubed plus, and you need something to the 3rd power, a number to the 3rd power that basically equals 8. Well, that will be 2, right? Because 2 to the 3rd power equals 8. 2 to the 3rd power will equal 8 right here. So instead of A, you're going to write C, and instead of B, you're going to write 2. So that's how we're going to factor this, and let me show you when you factor it. We'll just worry about this numerator right here, and then we'll factor everything else in a minute. You're going to, because this format says A plus B, basically what you do is take the bases. A is the base here, B is the base here, so in the example that we're doing, C and 2 are the bases. So it'll be C plus 2 to do a squared. Just substitute a c in there, c squared. Oops, sorry, that's a c squared. Minus a times b, which will be minus 2c plus b squared. Well, if b is 2, then b squared will be 4. All right, so factored. Again, here's what it is again. You need a base cubed. Well, in the example we're doing up here to factor the problem up on top, c to the third power plus b cubed would be 2 to the third power. Make sure both of these are in cubed form. Then you take c as wherever there's an a, you're going to replace with a c. So I replace it here, I replace it here, and I replace it here. Then wherever there is a 2, we're going to substitute 2 in for b. So I did it here, here, and here. And then I have factored c cubed plus 8. And then last step is we're going to just go up here, and this will be the last one I'll do because I'll have you work in your worksheet. Okay, I'm going to factor the c cubed plus 8. I just did that below here. C plus 2 times c, this was actually c squared. It was kind of hard to write with it. C squared minus 2c plus 4. Okay, and then the denominator, because it's a division problem, I'm going to take this denominator, c squared minus 4c plus 4, and put it on top, and that's going to be c minus 2 times c minus 2. So I took this denominator and brought it up on top, and it factored that way. Then we're going to do a line. There's my fraction bar, and now I'm going to take this denominator and put it on the bottom, factored, c plus 2 times c minus 2. And then this one's numerator is coming down because it's a division problem, and so that factored will be c. Let me just see. I don't know if that can factor, so I better pause. I think it'll be the same thing. Yeah, I can't factor that one, but notice I can leave it in that form because it's going to be the same as the trinomial that's in the numerator. So just leave that as c squared minus 2c plus 4. Okay, so once again, this is what I've done. I took c cubed plus 8, and I showed you how I factored it down here. And I took the factor of this binomial and this trinomial and replaced the numerator with those two polynomials. Then the c squared minus 4 is right here, c plus 2c minus 2. Then I've did the reciprocal of my second expression and took c squared minus 4c plus 4 and factored it to c minus 2 and c minus 2, and it is now in the numerator. And then this trinomial was not factorable, so it just comes down here in the denominator. But notice it is the same as the trinomial in the numerator, so we're going to be able to cancel this trinomial and this trinomial, this binomial, this binomial, this binomial, this binomial. And so all we're left with is c minus 2. And that's going to be your final answer, c minus 2. And since it's in the numerator, we don't have to worry about over a fraction or anything, because it's just c minus 2 over 1, and that would be your final answer. All right, Megan, hopefully that gets you started. Don't worry about these kind of problems. We'll keep going over them tomorrow, but hopefully that gets you an introduction to them. I want you to work on your worksheet now. This would be your homework for tomorrow, and hopefully Mrs. Carroll has a copy of it for you. It's the Rational Expressions worksheet, and you would do pages 1 and 2. It's basically 1 through 26, and you can work on that now. We'll see you tomorrow. Have a great day.